Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students all over the world. And as you know, we have started this book, Cambridge University Press Physics for Cambridge IGCSE course book. David Sang, Mike Follows, and Sheila Tope. This is third edition, and we have started this book from right from the beginning, and that is chapter number 1. And chapter number 1 was all about the measurement, was all about making measurements, and we have uh, learned to measure length. We have been able to measure the volume of anything, and now we are going to study density today. So density is very important thing, and we have already done a practical. But if we complete that practical, we'll be able to know the density. Remember my last question? Yes, about submerging a solid into the liquid. Uh, Let me just recap that thing. This was our graduated cylinder, okay, and filled with water, and we immersed a solid cube or whatsoever irregular body in this water. So we have learned to only to know its volume, but the density, finding the density is just like this. And the density, what is density? If we know the mass of the thing, if we know the mass, and if we divide the mass of the same body, mass of the same body with its volume, then it is known to be the density. D is equal to, or you can say it, density is equal to mass per unit volume. Density is equal to mass per unit volume, and it is known as like this. It is written as like this. This letter is a Greek letter, and it is rho. Okay, rho is equal to mass per unit volume. And how are we going to know? Well, yes, what is mass? First, let me uh, tell you what is mass, because mass is the thing which has came new in this. You know that W is equal to mg, or you may have studied F is equal to ma, or F is equal to mg. So many things I have written for you. You see that in all the things m is common. In all the things m is common, and these are all interrelated things. Mass is the matter inside the body. Mass is matter inside the body. It is not the weight. It is not the weight. Weight is the pull of the earth. The gravitational the attraction of the earth is called its weight, and it is written here. And mass, what is mass? Mass is the matter, inside the body, For example, if I am there, my weight is, let me say, my weight is 70 kg. My weight is 70 kg. When I stand on the platform balance, it says that you are 70 kg, on the digital scale. When I stand on a platform balance, it says 70 kg. Okay, it says you are 70 kg. That is my weight. Because earth is pulling me. I am affected by the gravitational pull, which is this. Okay, I am attracted by the gravitational pull, and in MKS system, the gravitational pull is 9.81 meters. Okay, it is 9.81, or roughly taken as 10 that is taken as 10 meters per second. Okay, now if this 10, I, because my weight is, how much my weight is 70 kg. Now 70. If I want to, find my mass, then what would be my mass? Then what would be my mass is equal to m is equal to w upon g. My mass would have been w upon g. If weight was, my weight was 70, then 7 divided 70 divided by 10, you see my mass is only 7 kg. 7 kg. My mass is only 7 kg. The matter inside me is 7 kg. So the matter within this block, within this pen, is called its mass. Okay, and mass is what? It is weight divided by the gravitational pull. It is weight divided by the gravitational pull. And if we know the mass of anybody, and if we multiply it with its volume, so we'll be able to know the value of its density. Okay. Now, how we can find the I started with an example. Of which we learned previously. So let me continue with this example. Okay. To know the volume of the body. To know, for example, we want to, now you see that mass is measured in, what is it measured in? I just told you that if my weight was 70 kg, then the mass would have been 7 kg. Then it means that mass is also measured in kg. But this is the, what is this? This is the density. This is the property of the matter. Okay, this is the property of the matter. What is this? This is the density, and density is the property of that material. And if you, just one example, if I put, this is a two pen balance. You see, I put a weight over here, 1 kg or 2 kg. Let me say I put 1 kg. It is a small piece of 1 kg, like this, about this much, because that is made out of steel or brass. Okay. Now, for example, this is 1 kg, and on the other hand, on the other pen, I put 1 kg cotton. If I put 1 kg cotton over here, then what will happen here? That the cotton will be very much big. About this much will be the cotton over here in this pen. Okay. In this pen, the cotton would be this much, and whereas in this pen, the weight, which we are going, now this is a comparison. Of weights. You see that 1 kg, and I have to buy 1 kg cotton. For example, 1 kg cotton. So when I say to the shopkeeper, give me 1 kg cotton, he'll put 1 kg weight on one side, and then he will put 1 kg cotton over here. We'll see that 1 kg weight. Okay, 1 kg weight here. Weight is a stone, or it's a piece of iron or steel, or it is a piece of brass, which is put at one pan, and then he will measure with the help of this 1 kg cotton. It will be about this much. Because the volume of cotton is different from the volume of the weight. Volume of the cotton is different from the volume of the weight. So there are different. There is always different densities. Now this is, I can say this is less dense, this is more dense. So it has taken very smaller space. It has taken very smaller space. Now this is less dense. It has taken more space. Okay. Similarly, if you if you take wood, if you take wood, and on the other hand, if you take a steel ball or steel maybe block or a steel ball, say a steel ball, you if you put this steel ball in the water, it will go down to the end of the, it will go down and settles over here, and settles over here. Whereas if you put wood over here, it will start floating, it will start floating on the water, it will start floating on the water. That means there is something which is letting the thing going down, and there is also something which is letting to float it on the water. It is going to float it on the water. So that very thing is the density. That very thing is density. The less denser things will always float on the surface of the water, and the heavier things will go down to the base of the water, and like the steel ball. Okay. Now, what I was telling you, so I have told you about the mass, I have told you about the weight, I have told you about the density. Now, let me proceed. Now, this is the density is the ratio. So, you see that density is the ratio of mass and volume. Or you can say density is equal to mass per unit volume, or mass per unit volume, and how we can find it. For example, if I want to find the density of unknown substance, I want to find the density of unknown substance. Maybe that is a stone, or that is any material made out of anything. Made out of anything. What will I do? I will just put that thing on the balance, on the digital balance. Okay, I'll put that thing on the digital balance, and I'll note its weight, because I can note its weight. I cannot read its mass directly. Okay, I cannot do it. Okay, now the mass of that very body, now this is, for example, this is a piece of iron or a piece of unknown substance. This is a piece of unknown substance. Okay, then I'll put it on the scale. I'll put it on the scale, and for example, it come to be, let me say that it come to be 150 grams. 150 grams. Okay. Now this 150 gram is the weight. It is 150 gram is weight, and then we have to find weight is equal to mg, and m is equal to w upon g. So since we have found the weight, we will divide it with the gravitational pull, which I have told you, is 10. So I'll divide this to get, I'll divide with g, and then I will be able to know its mass. For example, now the mass is, for example, is 1.15 grams. It is 0.15 grams. So I'll put this 1.15 gram in this, and I'll note the displacement. I'll note the displacement of water. I'll note the displacement of water. That means I have already done with the experiment which I did in the previous lecture, in the first lecture. Then for example, I have the graduated center, and then I'll note the initial volume. Then after putting this piece in this, I'll put its final volume, and then the displacement will be noted, and with that displacement I'll be noting the volume of the water which has increased. Then I'll be able to know its volume as well. The volume of this piece, the volume of this piece. Then I'll divide the mass with the volume. Then I'll know its rho, and rho is the density. Okay. Now let me proceed. Okay. Now what about the unit? What about the unit of rho? What is the unit of rho? Let me tell you before proceeding. The unit of rho, or the density in SI unit, Standard International Unit. Standard International Unit. Standard International Unit is kilogram per cubic meter. Is kilogram per cubic meter. It is written there. It is the unit of density. It is the unit of density. Okay, it is the unit of density, kilogram per meter cube, or you can say it kilogram per cubic meter. Okay. Now there are different densities of different substances. As I told you, the density of water is uh, taken as a standard. Sometimes it is taken as a standard, and the density of water is, here it should have been written over here, 1000. The density of water is 1000 kilograms per cubic meter. 1 kilogram per cubic meter. And what does it mean? What does it mean? If you have a tank, which is 1 meter here, 1 meter, this is 1 meter, and height is 1 meter, and it is also 1 meter deep. Okay, 1 meter breadth, 1 meter length, 1 meter height. Okay, that means all the three. This is a tank. You can say that if this is a tank, which is 1 meter here, 1 meter here, and 1 meter here, then the water stored in it. If we store water in this 1 meter cube box or tank, then the water stored in it will be 1000 kg. The mass of water will be 1000 kg in this box. Okay. There are, as I told you, that there are different densities of the different. Steel have different density, brass has different density, copper has different density, wood has different. Woods floats on the water. Ice is a very different thing, since it is a form of water. Three states of water. You might have studied three states of water, three states of matter, and ice is one of the three states which we look daily in our daily life. It is ice. Okay, it is water, and it is steam. These are the three stages of water, or three states of water. This is solid, this is liquid, and this is gas. Okay. Ice, the the density of ice is less than water. The density of ice is less than water, but it floats on the water like this. If this is the piece of ice, if this is the piece of ice, for example, this is one, let me say it that this is, if the, if it is 40 centimeters, I've taken 40 for my own purpose, for my ease and comfort. Okay, 40 centimeter, you will see that only 30 centimeter will float inside the water and 10 centimeter will float outside the water. It will float like this. If this is the water, if this is the water, it is floating like this on the surface. Okay, and the rest is like this in the water. Ice has a property. Uh, Dear students, now ice has a property that about 10% of ice floats above the water, while the remaining 90% is below the water. Why the wildlife, or you can say the sea life, is able to survive in the water. That's why it is able to survive in the water. Uh, See that this is a sea life. This is a sea life, and this is ice which is floating on the water. Now, there is one more thing for survival of this life is anomalous expansion of water. Anomalous expansion of water. Anomalous expansion of water. Okay. Now, more cold cannot enter into the more cold cannot enter into the water, and here it is minus 4 degrees centigrade, but within it is above zero. It is above zero. Okay, it is in plus. Okay, the temperature is in plus degrees centigrade. Here it is minus 4 degrees centigrade. Here it is plus degree centigrade. Okay, that's why the life under the sea survives for two reasons: nominal suspension of water, and similarly the igloos are based on the same principle. Now this was just to give you the examples of the ice, but I was telling you that gases have different densities, gases have different densities, and solids have different densities, and the um, liquids have different densities. The solids have more densities usually. Solids have more densities than the liquids, and liquids have more density than the gases. That means the gases have much lesser density than the two. Okay, that's why if I just spray a perfume, if I just spray the perfume, it just spread all. It just spreads in all the room. Okay, that's why, because the gases are evaporated very easily. Now, my dear students, you can see the different units on page number 6 of your book, and that are units of mass, unit of volume, unit of density, and unit of water. Okay, for example, unit of mass is kilogram. Okay, I have just written it over here. The unit of mass is kilogram, and the unit of volume I have written here somewhere is meter cube. Okay, cubic meter. It is in cubic meter. It is in cubic meter. And I have also written the density of water, that is density of water is 1000 kg per meter cube. Yes, I have written it over here. Yes, 1000 kg per meter cube. Okay. Now the different densities are given in table 1.3 of your book. The air have the density of 1.29 kilogram per meter cube air. Now you know the air is mixture of some gases: nitrogen, oxygen, hydrogen, helium. Okay, the most of it's nitrogen. Okay, it has the volume of 1.29 kg per meter cube. 1.29 kg per meter cube. It is the density of air. Similarly, the density of water, I have already told you. The density of mercury. Let me take the density of mercury because this is a very interesting metal. Mercury is very interesting metal. Why? Let me tell you. Okay, the density is 13,600 kg of meter cube. 13,600 kg per meter cube. If same is the box in which I put the water, 1000 kg mass, 1000 kg mass in the same tank. If I store mercury, that will be 13,600 kg. That will be 13,600 kg, whereas the water was only 1000 kg. Now you might have know what is the density. Now this is the heaviest end. Now this is the heaviest so far which we have stated. And the water is taken sometimes as a reference. The density of water is taken as a reference, which is 1000 kg per meter square, and comparing this mercury, which is how much? 13 times heavier than water. It is 13 times, almost more than 13 times, 13 plus times, you can say it, 13 plus times heavier than water. Okay, now it is the only metal. This is the only metal known to human which is liquid at room temperature. It is liquid at room temperature. It is liquid at room temperature, and that is why it is used in thermometers. And it is also used in mechanical technology, where we need to have the level of anything. For example, let me define you why we use it in the thermometers. Now this is a thermometer. This is a clinical thermometer, a very large one. I made a very large one. Now this is called the bulb of the thermometer. And this is the graduated scale over here, which is written today. It is nowadays it is written in both the units, Fahrenheit and centigrade. And there is a scale right here, and there is a scale right here, and a capillary tube. A capillary tube is given here. Now you see that it is filled with mercury. Now this is filled with mercury. As I told you, this is the liquid at room temperature. So it always shows you the room temperature. When you take a thermometer, put it under your tongue. With the heat of your body, the liquid expands. With the heat of the body, it expands, and of course, it does not have any space to go. So it rise on the it rise on in the capillary tube. It rise in the capillary tube. So your the temperature of body is noted, which is 98.4 degree Fahrenheit or maybe 34 degree centigrade. It is 98.4 degree Fahrenheit F, or it is 34 or 33 degree centigrade. And in mechanical, I was telling you, and in electronics, it is as well used, where we want to take a very precise level. Now there is a switching device. It is a switching device. For example, it is filled with mercury. It is filled with yes, and I told you about the meniscus as well. If you taking the mercury, you might have seen a blood pressure meter. You see that the meniscus of the mercury is always convexed. It is always convexed. It is like this, like my nail. Okay, because the force of attraction is lesser over here, so it rises from the middle. So it is always convex. So we take because it is not a transparent, it is opaque material, we cannot see through. Even then it is taken, the upper meniscus is taken as reading, and that is also known as in chemistry the symbol is Hg, and is taken as the blood pressure. Okay, now similarly, uh, when it is taken in the switches, for example, now there are 2 points. If this point, you see that this point is attached with mercury before it is switching on, and when a machine or any device is just horizontal to the ground, it is 0 degree horizontal, then it should operate. It is a safety device, is taken as a safety device. If the machine or the device is 0 degree centigrade, 0 degree horizontal, then it means that mercury will flow from here to here and will make this point as well. And the current will flow from here to here, and the machine will operate or the device will operate. Or otherwise, if it is in minus degree horizontal, that means it is not horizontal, it is like this, it is tilted like this, then the mercury will flow and will not make any contact. You see that mercury will not flow, okay, when it is, because it is liquid at room temperature. If it is uh, tilted on one side, then it will not flow. It will tilt it on one side or tilt it on the other side. If, for example, it is in the minus, and if it is in plus even, then the position of it will be like this. All the mercury will be standing over here. This point will be broken and this will be made, and it will be only working here when it is at 0 degree horizontal. So this was some information which were given to you. And for example, I was telling you about the different densities about the, now the ice has 920. You see, I told you 920 kilograms per meter cube is the density of ice. 920, whereas the water was 1000 degree. 1000. whereas water was 1000 kg per meter cube. Whereas water was one. So you see, it is almost very near to water. It is almost very near to water. So, as I told you, it will float uh, 1 by 4 over the earth, over the meniscus, and 3 by 4 under the meniscus. It will flow over the meniscus, 1 by 4 over the meniscus, and 3 by 4 under the meniscus. So, how will we calculate the density? Now, the question here arises that how will we calculate the density and how will we measure that? Now, calculating density. Now, there is a worked example given in your book on the same page which we are reading is page number 6. And to calculate the density of a material, we need to know its mass and volume. As I told you earlier, that we have to know two things. To find the density, we have to know two things. Number one is the mass, and I have told you how we take the mass, because we don't know I don't know the mass of this block. I don't know the mass of this block. Yes, I can find its volume, I can find its weight, but I don't know its mass, because mass is something different, and this is weight which is divided by gravity, which is weight divided by gravity, which gives us mass. And we have also to know the volume of that thing, and volume is always area multiplied by length, or area multiplied, you sometimes it is height, sometimes it is length, or sometimes it is height. For example, for this cylinder, the area is this one, area of the area, and the length or height is this. It can be also be said as length, it can also be said as length, height, or you can say, if it is like this, it is a cube, so each side is s, so it is s cube, and of cuboid the area is length into breadth. This is length, is breadth, this is height, because length has already been consumed over here, so it is called length into breadth in height. So this is the volume, so this is the volume here, this is pi r square into height, this is the volume over here, and this is the volume over here. Okay, and for sphere, this is the volume. Okay, pi r cube for sphere, this is for sphere or ball, sphere. So these are the volumes. So these are the volume. We must know the volume of that thing. We must know the volume of that thing. For which we have to find the density. And because the density, the formula of density is rho is equal to mass per unit volume. Mass per unit volume. We have to find, if we want to want to find the density, we must know mass, we must know volume. And I have already written the volumes of cuboid, volume of cylinder, volume of cube, volume of sphere. And yes, we can find the volume of irregular unshaped bodies, okay, with the help of cylinder or the water experiment which we done in the previous lecture. So let me explain to you now example number, and then we'll finish and we'll be now. A sample of ethanol has volume of, now ethanol, it is a liquid, ethanol, and it has volume of 240 what, centimeter cube. It is centimeter cube. And what else we need is its mass, and its mass is found to be as and ethanol volume, and mass is equal to how much is given? It is 190 grams. It is 190 grams. Okay. Ethanol volume is 240 centimeter cube because it is volume, and mass is 190. We just because the uh, units are in the same system. This is centimeter, this is gram. If this would have been kilogram, we should have been changing it into this would have been in meters, we have to change this into kilogram. If this is was in kilogram, we have to change it into the kilometer, into meters. Okay. So since these are in CGS system, it is centimeter, grams. So these are in one system. Okay. No problem with the units. Okay. When there is no problem in the units, we can proceed. And if there is some problem, as I told you, if this was in meters cube and this was given in grams, then we have to change one out of two. Either we have to change it into centimeters, and or we have to change this into kilograms. And if this was in kilograms, then we have to change this into grams or this into centimeters. So there is no problem with the units. Okay. When there is no problem, we can proceed. Write down, you know that we want to find the, now we want to find the row. We want to find the row. Okay. Okay, now this is was the step number one, collecting the data. Now these have been collected from the given things which were in the question, which were in the question. So this given things were in the question, that the volume is this, mass is this, and we have to find this. Okay, it is very simple that rho is equal to m upon v, that is equal to, so mass is equal to 190. Okay, grams, you can also write the unit along with. Okay, 190, this is 190. Okay, and divided by 240 meter cube, centimeter cube, it is centimeter cube. Okay, it is centimeter cube. After calculating, what we get is 0.79 grams per centimeter cube, because you see that this will also be written, this fraction will also be written along with the density. Now this is the density of ethanol. This is the density of ethanol. The density of ethanol is 0.79 or zero point 0.8 grams per meter, grams per cubic centimeter. Now if I want to find the mass of a regular figure, if I want to find the mass of a regular body, for example, I want to find the mass of the book, or I want to find the mass of this brick. For example, this is a brick. Okay, brick, the thing from which we build a wall, we construct a wall. It is a brick made out of stone. Okay, we have to find its volume. And I've told you the volume, how it is taken, length multiplied by breadth multiplied by its height. That is the volume, and then I'll weight this. I'll take the weight of this. First of all, if I want to find the uh, density of this brick, this is a brick. Then first of all, what will I do? I will know its mass. For mass, I have to take its weight, because I cannot directly take the mass of this brick. I cannot take directly the mass of this. So I have to take its weight. For example, its weight is 4 kg. 4 kg. I'll divide it with 10 to get its mass. Now the mass will be 4.4 kg. The mass will become 0.4 kg. I've already know the volume. Volume was of the cuboid. Volume was length into breadth into height. Then we'll uh, apply this formula and we'll be able to know the measure of the density. This was how we measure the density of the solid. And if we want to find the density of water or liquid or whatsoever it is, what will we do? It is a little different thing that the density of water. Now it is very easier, more easier than the weight. Okay, this is a cylinder, again a graduated cylinder. We put some liquid in this. We don't know what liquid is it. So what we'll do, we'll weight it. Okay, we'll weight it on the digital scale. We'll weight it on the digital scale. Okay, after weighting it on the digital scale, we'll able to know its mass. How? You know it, how we know the mass, and we have already know the volume, which is over here. The formula will apply and we'll know the density of the liquid. Okay, so this is the very simple thing of finding the density of what liquid. So my dear students, this topic has ended and we'll be able to do some questions on this after we'll be I have still one measuring time. Yes, I have still one topic left and that is measuring time, which is very, very important. I hope you would have understood and enjoyed the lecture of physics today. So it's time to say you goodbye. But before saying you goodbye, I'll just request you to like, subscribe, and share to my channel to your family and friends. And also, you can post your comments in the comment section, and you also tell me from which country are you watching my videos. Okay, it's time to you say you goodbye. Allah Hafiz.